Thank you very much for joining in today. So this is the session where we're going to be presenting to you a design. So this is the result of a quite long process. Long process. We've been working on this for about 1.5 months, 2 months. And so the idea is that about half of the world population actually depends on the sea, because either they live next to the sea, they are feeding themselves from the sea, or they work in an industry that's dependent on the sea. And so all life that we know on Earth comes from the sea, yet there's a tremendous amount of pressure on the sea, whether it's pollution from plastic, from oil, from industrial agricultural runoffs, urban runoffs. So there's an increasing need to extract and to exploit the sea. At the same time, there's an increasing pressure on the sea. There's also more and more projects out there that talk about making floating settlements, or for example, in the case of Hong Kong, to make a large reclamation project like the Lantau Tomorrow. And those projects are sometimes viewed as necessary to be brought at large scale, but we generally don't really understand the implication of the ecological impacts or environmental impacts of such large projects. And so what we're saying is that instead of having an architecture studio, which we're saying, oh, hypothetically, let's build a giant city out there. The idea is, how do we work with real scientists and test a lot of the hypotheses that are pushed forward? Because a lot of these projects would say it's going to be an ecological city, it's going to be on the water, it's going to be good for the environment. But actually, there's very little evidence for that. There's very little precedent for that. So what we want to do is to make small pilots and build the knowledge that's going to be necessary for us to understand how we can live for example, like in an urban way, in high density, and with the sea. Or maybe this is not the way we should go, and it's not possible to do that, and therefore what else we should be doing. Coincidentally, at HKU, there's this amazing group called the Ocean Research Alliance. This is a brand new research group, not official even yet. We don't really have like a public website. I mean, the website is there, but it's still like under construction. We have some representative of the ORA that joined us today, so I'm very, very grateful that you guys joined, because in fact, this whole architecture is really, you would be the primary user for this architecture. So your feedback would be really the most valuable. Is how can we build this platform so not only it can serve the community, but can also create new knowledge and can be disseminated and publicized and peer reviewed. So that's really a key part of this project. So the students have been divided into different research areas. Some of them are, or maybe stakeholders groups, so they represent the interest of different communities. Some of them represent the interest of the ocean scientists. Some of them represent the interest of the fishermen, the people who are just living there on the waterfront or live in the coastal communities. Some of them represent the shipping industry, and the other one, the NGOs. So they all did conduct their own interviews, field work, and they actually came up with all the design you're going to see today based on those investigations they have done prior to designing. The project is working on the principles of open innovation. So you have several steps. First steps, you see with all the little spheres on the left, the students all make their individual designs. So all the students have the opportunity to express their personal creativity. The second step is that we kind of narrow down to like a group, so group designs. And then the last phase in which we have entered on this very session is that now we have one design that we'd like to submit to you for your feedback. And based on your feedback, we're going to refine the design, and then eventually we're going to be building it and putting it in the water. So your feedback in this session today is extremely important, because as much as possible, I'd like to do something useful. If you see that you could actually collaborate with us in the next 1 month, 2 months, and you have some ideas you'd like to test in the water, or you have a site that you think could be suitable for testing this platform, then this is the perfect time. We have been working in a very collaborative and transparent way. We can share this presentation with you, but basically you can see here the whole process of having individual design, group design and feedback, and how we've tried to really put all the best ideas into one design that we're going to be presenting to you right now. So there's going to be a 15 to 20 minute presentation by the students, then a 20 to 30 minutes discussion, and then a debrief and a closing remark. I would love the closing remark to be done not by me, but by members of the ORA, if that's possible. So at least we also get another perspective to this story. As I mentioned, what's most important in this gathering is not that we think, oh wow, this design is really cool and exciting, even though it's encouraging for the students, but what's most helpful is if you can give some feedback to the students. So if you can scan this QR code right here, that would be basically linking you to this questionnaire. And this questionnaire, it's very simple. It's asking you, your name and your background, what's your research interest, but it's asking you like, how do you think this can be improved? What do you think is the strength of it? And you have reference and things that you think the students should look at as a further inspiration. And then there's also a question about the site. If you have access to a site that you think would be a good place to test the platform. So please scan this QR code, and I'm going to share the link to this questionnaire as well here in the chat. So I will put the questionnaire in the chat right here, and I will put it right in the chat for everyone here. It's here. Okay, this is not for Judy Gaetan, I want this to everybody. Okay, so this is the form for feedback. Okay, so I don't want to take more time from the students, and so let's jump right into the presentation. So this is our proposition of a floating marine laboratory.
Okay, so the major issues, challenges that we're facing are that research platforms nowadays are very expensive. Most of them are kind of boats, which are not only expensive to build, but also expensive to operate. And this limits access, research, and educational possibilities. The second thing is plastic pollution. As you all know, a lot of the plastic ends up in the ocean every day and enters our food cycle. In Hong Kong, the public waterfronts are often separated from the water, so there's little to no space for interaction for the public, which is very sad to see. And also the fourth topic is the unsustainable fish farming, that a lot of fish farms pollute the water with the fish waste, and also the fish themselves are very prone to diseases because there's not enough space and no mixture in species. Next.
Yes, and we did a lot of research about how to deal with this challenge in the ocean. And as architecture students, we designed many different applications which aimed to help the ocean become better. And as you can see, there are all the sketches from individual design from students. We designed it in different directions, try to solve the different problem in the ocean. And next, please. So finally, we try to combine all the idea together in the harmonic relationship and also make it work in high efficiency. So we use hexagon shape as a fundamental structure of a floating platform, and divided in 7 parts, and put every system in each part. You can see here have a aquaculture system and education and underwater whaling system. Also, it's a trash collection system. And for work style, because this platform is not very complex, so one person is already enough to carry the daily maintenance for the platform. And because we have education and underwater whaling system, so this platform should carry 10 person to visit max. Yes, and next they will to introduce more detail about subsystem.
Yeah, so the first subsystem we're dealing with is oceanic plastic pollution. because by 2050, the weight of plastic to the weight of fish will be like 2-to-1 in ratio and in the ocean. And so it's very urgent. So we have interviewed different experts and gathered their thoughts here, and we gained several ideas from them. So firstly, we as consumers or enterprise or governments actually have equally very important role in the issues. Like the enterprise can reduce the package complexity whilst the customers can actually choose lesser package wisely. And very importantly, the government's policy on polluters pays principles, which unfortunately hasn't been implemented in Hong Kong. And all this would just reduce the amount we have to collect from the ocean when we can just reduce the source. And secondly, the message from WWF, Lydia, perhaps just advocates that we can have collaboration between different industries related to the ocean. She made an example. We could just build up a good relationship with fishermen. If we do so, we can actually build up agreements with them to avoid their unwanted nets, which at the end become gross nets released to the ocean. And concerning recycling after collection, from what recycling activist Adam Wong has said, it is far more effective to sort and filter materials before they actually bring to recycle. So all this actually gives so much inspiration towards what we wanted to incorporate in our design. Yeah, and Calvin will explain a little bit more about our proposal on regarding this system. If we go back to the page before.
So based on the expert suggestion, we are proposing two strategies in terms of dealing with ocean plastic pollution. One is about filtering and one is about collection. So the ideas about filtering the marine debris is to avoid the accumulation of the ocean debris over the shore, and also protect the marine ecology and also their lives around near the shore. So and also to separate the waste in different sizes, so which could facilitate the recycling process in the next step. And the second strategy is about plastic collection, because we all know that the amount of plastic debris over Hong Kong is quite large, so that our laboratory is not possible to have a one-time solution over such a huge oceanic debris. So our device would act as an experiment on how to effectively collect the ocean debris using different mechanics, and also trying to retrieve the data about the debris that is collected, so that the tracing of the source could be suggested maybe to the government or to the NGOs that could have further actions on application or regulations and policy, etc., to deal with the problem from a top-down approach. And also we would like to propose a feasible business model for plastic recycling through our experiment on this floating marine laboratory. Next, please. So this little diagram is showcasing how the relationship of our floating marine laboratory could be done, dealing with different stakeholders like the government. We provide data for them. We experiment on the collection of ocean debris. We raise public awareness by education, and also provide business model to the industry, like in terms of this cycle. Next, please. So we have also looking into the references of different methods or mechanics of collecting ocean debris, like the sea beam using suction, the trash wheel using a mechanical conveyor belt to grab the ocean debris from the river. And also there is a bubble barrier which produces bubble underwater, so that the ocean debris is blocked from going onto the shore, like in the diagram in a second row. And the last one is about the ocean cleanup, which is a very large scale device that grab the ocean debris from the oceanic, the Pacific area with a very gigantic buoyant devices. Next.
So in our system, we want to incorporate two elements in the final prototype we will design. So the first one would be about research. We want to set up a platform to study opportunities for different modes of farming, for example, seaweed farming and fish farming, so that we can research to see if we can find a balanced economic model, sustainable economic model for fishermen, so not to rely on only one form of farming. Also, by designing the prototype, we could study the aquatic species living on sites, as this prototype is meant to be mobile and could be implemented in different sites. The study could be implemented to different areas of the Hong Kong waters. And the second element we would like to introduce is education, which targets as the general public. We can present the different farming practice through the public engagement work, as we have seen in the general concept. We can also show the importance of maintaining good water quality in ocean sustainability. And we also ambition to root long-term effects like raising public awareness on coastal environment conservation and the reduction on ocean pollution, as we see there are lots of trash in the ocean, and most of them are done by members of the public. Next, please.
So number third part of the subsystem is about the farming fish and algae farming. And before I talk about the algae farming, I would like to say one of the reasons of that is one of the reasons is about the algae bloom. So which means there's no oxygen in the sea and the covered lighting in the sea. So actually we can try to collect the algae from the algae blooms in that zone area. So this can help prevent the pollution occur. So and also the algae farming system aim is misuse of the algae bloom area, and collecting the algae can help minimizing the oxygen consumption from algae. So it's kind of the one of pollution control. And at last, the production of the algae farming is can provide the energy source, fertilizer, industrial and commercial use of the algae. So this can help develop from the pollution control. And maybe because there's a second subsystem about the education, so this also can be part of the education from the algae farming. Okay.
And we also engaged the fish farming in the system because there was urgency to develop a sustainable fish farming system. That is due to the increasing demand for seafood and the nearshore aquaculture pollution, as the waste will accumulate at the seashore near our community. And what we want to engage in the system is a sustainable fish farming system, and it will use mussels and oysters to absorb the fish waste, and also use the seaweed and oyster to purify the water here. And in this system, it can provide diverse seafood for people to get.
So there is 4 types of targeted user of our platform. The first type is ocean cleanup organization. So they will clean up, this organization will invite volunteers to help with removing trash and collect it from seawater. So this will be done on a weekly basis with volunteers in group, and these collected trash will be analyzed. And then we suggested some activities which is some cleanup workshop which can promote to public like family and students. And then we would like to present the data collected from the trash to public. And then also we would like to there will be assistance in maintaining the trash collection. And the outcome would be promote cleaner ocean to sea activity and the ocean habitat, raise awareness to the ocean trash and sea pollution, as well as provide cleaner water to fish farming. Next. So the potential organization we would like to partner with is the Hong Kong Cleanup. So it is basically very easy to create your own event. Like you can just sign up and then invite volunteers from the public to help clean out. Next.
Yep, so for this, so for next
category of users is going to be the fishermen in Hong Kong. This is they will be actually we allow them to actually operate a small business on our platform in terms of fishing small amount of fish with our devices. So they will actually have to have a kind of regular check and feeding sessions on the fish farming on regular basis. And also the suggested activities include them introducing fish farming process to the visitors, promoting environmental friendly practice in the fish farming industry, and potentially sell fresh fish to the visitors seasonally. And they also are responsible for assisting the maintenance of the fish farm. So the outcome for this users is actually, we hope they could actually gain side income from the platform, promoting a more environmentally friendly kind of fishing techniques to their industry. And also we enable them to kind of engage with the public in terms of helping them to gain knowledge on fish farming and kind of the farming culture in Hong Kong. Next. Yep, so a little bit of the kind of background is that most of this kind of small scale fish farming in Hong Kong is operated in kind of small and family basis license, and it's also a licensed operation. So it attributed to kind of 5% of all locally consumed live marine fishes. Next. So we also have studied on over there are 29 different kind of areas in Hong Kong right now. They are doing this kind of small scale fish culture and also farming. And those kind of maybe one of our consideration in the site. Yeah.
Sorry. So another potential target group is students aged 12 to 18. We believe they are the best groups to be educated on because they have the incentives to help and raise awareness of marine litter among their friends and families. The educational topic that we want to focus on is marine litter by utilizing marine debris collectors so that the students can see the impact of litter in the ocean. Some suggested activities can be learning about the ocean debris filter system, clean out the debris from the collector as groups, and organize them into recyclable and non-recyclable piles. There are also a few outcomes we want out of this. The most important one would be letting the students feel accomplished in making a difference, be more aware of their littering habits, and becoming knowledgeable in ways of protecting our oceans. Next, please. The reason why we chose that educational topic of marine litter is because it's very important to educate young generations on the severity of marine litter in Hong Kong. We're very often unaware and detached from the issues and consequences of marine litter. So it's very important for us to educate the young generations so that they can start to help resolve the problems and educate the newer generations further down the line in their lifetimes. Next, please.
And the fourth targeted user for us are families with young children aged 6 to 11, because at this age, they're able to make really strong connections with new experiences. And we're hoping to create educational and fun activities that can engage and simulate them. So what we believe is if they can make fond memories, they will want to protect the ocean. So we want to utilize fish farm and algae farm so then the children can have firsthand experiences with the ocean and marine life. Suggested activities are to participate in the fish farm scheduled feeding. They can learn about the zero waste fishing system and also take part in planting algae in the platform. And the outcome that we want is that children can feel energized with such hands-on interaction with fish and algae, since it's quite rare in Hong Kong. And hopefully we can foster long-term relationships between the children and the ocean. Next, please. And we chose the educational topic on marine biodiversity because I feel like Hong Kong people don't really know how diverse our oceans are, and it's really important to introduce this to young children so they grow up having a relationship with the ocean. An example here is the Ocean Recovery Alliance's annual Ocean Day. So they do this every year and they invite children to the beach and they create ocean awareness for the next generation. Next, please.
So the hope to impact, just to kind of to wrap it up, is to get all these group of different people to work together. So the ocean cleanup people, the fishermen, the students, and the families, to have 1, a cleaner ocean, 2, economic activity, 3, education, and also entertainment and tourism, so to bring everybody together. But because the goal is also to develop research, is for the ORA. So the idea is that the ORA can actually work with those different groups, and they don't have to perform all the work together. They can actually work with those different groups that can help to be like citizen scientists and be on the front lines, so that they'll be doing a lot of the heavy lifting work. So it's more about building a system and then maintaining those relationships, and then the stakeholders would see the benefits for themselves. So the implementation, how we intend to actually build it.
We are trying to develop the whole design into reality. We come up with different ideas about how we're going to build it. There are some details to show. For people to get access to our floating lab, we would like to introduce modules of Pontoon which are connected to the Hexagon platform. This is a simple method how we build a pontoon. We use 2 PVC pipes as a base, tie the stainless steel angle with ropes, and finally cover them by wood board and fixed by screws. This pontoon units can be joined end to end, so we can build a long path on the water. Next, please.
And to join the hexagonal shape prototype together, we are going to use the PVC tubes, and we're going to, because each of the angle is 120 degrees apart, so we assume that they're going to be proprietary fittings. And with the use of PVC adhesive, we're going to strengthen it together. And we're going to, the dimensions are approximately 3 meters on the outer edge for one side. And we're going to offset around 700 for a pathway or walkway for people to go through. Next, please. So to stabilize the structure during storm, we're going to impose this parachute structure into the ocean, and to conquer the wave action that it brings during severe weather conditions. And if our structure is really big, we could also use this method to kind of balance it as well. Next, please.
So structure consists of different programs, including fish farm and also the trash collection. So we have a bubble barrier, which prevent the fish from mixing with the plastic. And then the bubble barrier is basically an air pump. And here we try to integrate a water wheel to generate the movement to activate the pump. And so the whole system will be non-pollution, not causing any pollutant in the water. And these are potential material we can take from the local, yes.
We are looking at different sites, so we start to have some discussion. For example, I mentioned Hoi Ha one. So I went to visit Richard and then Tom recently. But what I'm saying is that we are looking at those different sites. Also, there's Hillian, who suggested Shui Hui Bay. I know that there's some members of the SWIM also who have this site in Cape d'Aguilar. And so we would love, so those sites are sites that we are thinking about, but depending on the application. So if we can collaborate with some of you, maybe there will be an interest to put in a particular place. So in the questionnaire and just now in the verbal feedback, we'd love to hear whether you have a suggestion of where we should put this kind of floating platform. Maybe where there's also more plastic, or where there's more fish. We are very, very open to a location. So this is it. Thank you so much for listening in. So I mentioned that we have prepared this form. So because we are very, very lucky to have many amazing guests and reviewers, and we want to make sure that you all get a chance to share your knowledge. I also got an email from Professor Gray Williams, the director of SWIMS, And he mentioned that David Becker is here, but what we should do is maybe next is to organize a workshop where they tell us how they would want the platform to be set up. For example, like how to organize the tanks and so on. So we are really looking forward for this session. But now I would love to hear your feedback. So what is your impression? What do you think are the strengths? What do you think are the weaknesses of this design? How can we improve it? We'd love to hear your thoughts. So maybe I'll kick it off with Margaret and Evan, because you guys have been running a similar workshop in the US.
Well, it's the scale is sort of similar to our Float Lab. I think it's a little bit bigger. How big is it actually? The dimension? I might have missed that.
I go back to the slide here.
3 meters each side, I think. So.
So what is the scale you worked at?
9 meters across.
Is it about 9 meters across?
10 meters,
10 meters across?
Yes, it's 8 meters across.
Okay. Yeah.
Yeah. It seems, at first I thought, wow, there's so many programs in one type of floating, so many intentions and uses in one unit. But then I was convinced actually at the end, because I think it is true that one can inform the other. I think having contact with marine life is a different, juxtaposed with trash makes it very evident very quickly who you're helping, who this collection of trash is benefiting. So it feels very direct. And Cesar, you don't know this, but maybe your student, I think we might flip, because as we're working right now with a team that is actually doing something similar, an outcome in terms of what we're not doing fish farming, but it's definitely plastics. So at some point, maybe we can have your students critique our students. It's just one team, but they're dealing with similar issues for the Bay. So public engagement, very important. Scaling, so research, we're looking at a scaled solution. And I guess that would be one question about, I think, how this fits into many, because you have a hexagon. So I think you're talking about what's possible as they group together. So I think that would be helpful to the projection of you're doing one, but how then does this scale to, as a way to help people understand the implications in the future of one. But the materials, I think that wasn't quite clear to me. This thing floats. Other than I see that the straightforward pontoons and things like that. But I see in the rendering, it's this wooden platform. So I'm assuming the pontoons are underneath and there's some kind of decking. Is there some kind of decking on top, some kind of wood decking? It looks like wood.
Maybe you could have the response from the construction team. Construction team. So we have Canosa and other.
I was also curious, real quick, just about how those rectangles turn into the hexagon as well while we're on the construction. I didn't make the connection.
Yes. You're absolutely right. Well, those look like the straight. I was thinking those were the straight runs, like the walking platforms between. But it is true. How does it create the hexagon? And
can we have the students jumping in and responding to the feedback? Construction team.
Are they muted? They might be muted. I don't know.
Oh, they might be very shy. Hello. So students in the construction, you have Canosa and other have students? Okay, if there's no answer, I just want to mention the gentleman who just jumped in. His name is Andrew Quidmeyer at NUS in Singapore, and he's built a project called Float Lab, which is a fascinating experiment in the Philippines. So that's something that we also took inspiration from, that I've also shared with Philippe, who is moving to the Philippines as well. The students, can we have somebody from the construction team responding to how they intend to make the platform floats? And what part of the module goes where?
I think the rectangle and the square part kind of plays into the extensions of this in this diagram. So it's kind of like a pathway that allows people to go through, and we might have done it in a modular case because of the wave action, where we kind of allowing some sort of discrepancy between the heights so that it doesn't break easily. I'm not sure how to like really say it, but because of the wave, it kind of like shakes apart. And if we dissect it in parts, then it won't crack that easily, I think.
Right. So they're like they're joined. So that's not clear here, which doesn't really matter because this is an overall diagram. But that, I guess that's the confusion, is that you actually are building in control joints, and that there are moments, especially off of that internal hexagon, that would have the ability to move.
Yeah, and you're also going to really have to think about how these are connected to, and what kind of dampening you're going to put in between them. You know, even if it's just ropes, how they're tied together. If they're really stiff versus if they're really loose, you're going to have different types of weird play and ability to use it.
What is what were you saying about the ropes where?
At each joint.
Oh, you know, one thing that our naval architect you might look into in terms of even protections at ends, that was a very simple thing. It was called the boat puttings. You know, where it's rope. You tie rope around the front.
And it makes a cushion.
A cushion. And so it's a really low tech, but you know, I think rope is amazing, actually. So I think we don't think about it enough, and especially in architecture school, we don't really think about that. But the idea of puttings between joints, or between, especially like there are moments that those kinds of simple things, since you're going to be making it, could be actually really useful. So you could look that term up, because you'll see them on boats.
Yeah, and even in the Philippines, we use the discarded tire straps, like sliced up bits of tires to kind of loop-like pudding between the things to help dampen that wave action, but still let them move around and stuff like that.
So I think it's nice that you have these different sections. You know, they're almost like kaleidoscope, you know, pieces, you know, that are all different. I think you start to differentiate them a little bit. So the one that's a trash collector might look a little differently. It might even extend out a little bit more, because it's going to have to kind of be, you know, it's going to have to accept the current in a different way than, let's say, the fish farm would, which might have to be more enclosed. And then, you know, the algae farm can start to maybe move out a little bit longer, you know. So I think there's ways to sort of show a kind of variability, because each one of these programs is essentially an experiment, right? It's gonna need, the more flexibility, you know, the more opportunity there is to vary the experiments, the better there is. So,
right. So they're
and
not.
It seems like like a very large experiment too. Each one of those.
Which is that's the that I would love, especially scientists, because it's a scale that is kind of lab-like. It feels like you're creating a lab, yet it's at a scale that's much larger. I wondered what kind of depth this is attended to, like how deep mussels with aquaculture. What kind of depth do you need in the ocean?
Maybe I see Thomas. You're thinking, what's your experience? Like, how deep do you think this should be? Like, where are your structure anchored on the seafloor? Were they in the fresh water, or where were they?
No, as I explained, I haven't really built a marine version. So I wouldn't know exactly how deep. But actually, the students, I looked through your website, and in their earlier work, they did have a section that shows the depth.
Well, I think it would be to get the mussel, the algae, the fish. There's probably an optimal level for that kind of system that you're creating, and so that might help determine what kind of depth and what kind of currents. I'm sure you want currents, and more flow, that always the better for all animals and marine animals.
We have several ocean scientists, I think, who are in the chat. We have Professor Kenneth Wong, Chung Ho Liu, Jing Wu. Maybe you would like to share your comments on the designs. Professor Karen, what do you think about the proposal?
Cesar, actually, before, can I just jump in with a quick comment?
Sure.
Because it just seems to me, yeah, the six kind of programs that can all mix together, very Hong Kong style, very high density, compactness. But my question is to the ocean scientists, the various programs, they need various sizes and volumes under the water. But how about the movement? Does the station, the lab, needs to move for some of the programs to work better, or does it stay in one place? Yeah, so I was thinking about the trash collection. Does the lab just stay there and then wait for the trash to float in, or does it move around to gather? And if so, how does the algae and fish farm and the mussel farm work together with it?
So, question for the students, please.
Yes, because we did some research about zero waste aquaculture farm. So that means the mussels and the algae, they can eat the fish waste as a food. So that is like zero waste. So we think we put them together as one farm. This make a sense. And also trash collection, they also can double check which fish cannot go out and to pollute the ocean.
And I think our trash collection part should be in a static way because of the amount of oceanic trash is really severe in Hong Kong, so that they are actually floating in while the tidal is surging or the wave is coming along. So I don't think that the platform will be a movable one. So that it's static, but then the trash will float into the device, so that the trash collection could filtering them from attacking the algae and also the fish farming. Yeah.
Okay, so I guess it will be kind of towed out to the sea in the open water and then anchored somehow or stabilized.
Yeah, I think so.
And we actually have several sizes of the mesh for collecting the oceanic debris. So when the tidal surges, the water comes in with the debris can be passively filtered with different sizes. So this echoes to our concepts of actually sorting out before recycling. Yeah.
Okay, thanks.
There's also the possibility for when you were talking about how it's anchored, for it to kind of operate where it always faces a certain way in the current. So as the current changes, you could always have that trash debris there, and that tail that's where the bridge is would always face, away from the current. So I think there's I think there's an opportunity to think about how it's moored, that it could actually begin to rotate. I mean, it's a perfect shape to sort of, you know, spiral around, and thinking about how it's anchored and where it could be anchored, I think is a good thing, given the shape.
One of the big questions that jumps out to me when I first see the design too is, are there any plans for any kind of like sun protection, or maybe even, you know, other kind of weather protection just for people who are on top of it? Because if it's big and open and, you know, you're in Hong Kong and it gets hot, and you're just baking in the sun, it might be a little tough to work at times. You might get cooked. And I guess a follow-up to that question is, what do you imagine the role of people who are actually on this thing? Are people going to be carrying out experiments? Do they just stop by really quickly and collect data? Do they just turn things on and off? Or are they hanging out there? Also, this is a public space. How do people get out there? How far away is it from a place where people are? Is it like right next to, you know, the shore, or is it, you know, you have to, of course you were looking at different sites already and stuff like that, but I think a lot of the questions will depend on like exactly what people are doing here just on a daily mundane basis.
The students, I think, might want to jump in, but maybe I just say briefly, I think you're right, like the really practical running of the space, I think is going to be really a lot defined by, first, what's the research interest, second, like how can the public can be associated and kind of execute those research interests in a way that's going to be sustainable, because people who just come for the first time, they wouldn't know how to operate the experiment. They were like, okay, there's nobody, like you said, like there must be some shades. So there's sort of an operator. I think that's something that Pia is very familiar with there, and Tom at the WWF Center in Hoi Ha. So yeah, so I imagine there would be like operators, and you would need to be close to the shore so it's easy to get there. The Hoi Ha Center, I think it's the bridge is connected to the land, so that makes it easier. But in this case, if we have to come by a boat on this one, I think that would pose a certain challenge. I see some really interesting questions in the chat coming in as well. So I see, how far is that going to be out in the ocean, and also how do we get there? Do we have some students who can try to provide answers to those questions?
I think the plan would be to stay rather close to the shore, but as you mentioned before, some of the uses require some kind of depth of the sea, especially the fish farming and algae farming. So ideal location would be rather deep, but close to the shore, so that is easy accessible by our, like the pontoon walkway.
There's another question about the cooling of the equipment, like computation power and servers on top, like electronics on board. And also a question from Andrew, how do we have electricity on board, basically? How do we provide electricity for the station?
So regarding the requirements of computer servers and cooling and ventilation, stuff like that, I think we have not thought about that in depth, to be honest. Regarding the electricity, an idea like solar panels came up, but then that can only serve for certain electronics. So whenever we need like a huge pump or something like that, we might need access from electricity on land, which then refers back to it's better being close to the shore because it makes that a lot easier.
Yeah, I have a few input about this because I have performed some little study about some data centers, okay, which can store a lot of servers undersea. That was actually employed by Microsoft and Google, in which they have a lot of servers for storing the cloud data. You know, those data that we store in the cloud are actually stored in these secret data centers. So in the data center, the ventilation is a big problem because you don't want the servers to get overheated and catch a fire. And also because of the energy issue, it needs a lot of air cooling. So that is why they put the data center into a submarine-like capsule and put it into the sea. Okay, put it down into the sea so as to provide natural ventilation. Yes, exactly, right. So the picture that you show is the NAPTIC project from Microsoft. So I wonder whether this could actually be also a good opportunity for us to explore on whether it is possible for a floating marine lab like this, okay, to have more environmental friendly and natural ventilation provided with energy saving. Okay? So even though I don't expect that you have a lot of servers or machines, okay, compared with a very big data center employed by these high-tech companies, right? But at the same time, I think the requirement is still here. And maybe you can take reference at a look at how they design these undersea data centers to see how you could still provide a safe and reliable data repository source for the data that you collect from the undersea, and how this data could be shipped and transmitted, okay, for further analysis. Okay? It's also an important question. Right? So you could not just accumulate data and buy hundreds of hard disks and store in this lab. Right? It is not possible. So in the end of the day, this data also have to be communicated through wireless or wired channels, okay, back to somewhere a larger computing facility for analysis. So how can you carry this data conveniently in real time if possible, so that you can have faster study or analysis of this data, rather than waiting for this data for accumulated for a week before bringing it manually back to the surface? I think that is some interesting question that may be considered. Yeah.
Yeah, indeed, you're right. Thank you very much for that input.
There are more questions, I think, coming from Andrew. He was asking if we're going to have permanent staff, and I think Pia has a question in the same direction. Who is asking, are we going to have like do we have 4 staff, for example, like on board? Like some of them teach us about algae, some of them teach us about plastic, or is it like how does the team on board looks like, and how many people basically are based on the platform?
So I think regarding the size, I don't know if it's gonna be permanently staffed. That depends on also which touches another question, which is the modular idea. I think it depends on how many of those things are connected, and maybe some of them can serve a different use. So then one of them will be also for like permanently staying on them. But I think right now we're in a phase where we have not thought in depth about how we're going to staff it and how we're going to run it afterwards. Because we're still in the kind of stage of finding out how to combine all these different uses that we want to do into one like kind of platform.
Maybe I can kind of turn this question to Andrew, because Andrew, if you're still here, are you there? Because you run this float lab. Was it thought as a performative architecture, something that was just going to happen for a moment, or did it have like a longer life and then people used it and then changed the use over time, or how did you conceive of it, and how was it run after you left, possibly? Yes, you.
Me?
If that's okay to put you on the spot. Yeah.
Oh, no, it's fine. And a lot of things I really want to bring up. So like, for instance, when we were running ours, it was set up for the public, and we had a $10,000 US budget to build the whole thing. We built the whole thing for about $2,500. It was about the same size as this. There were solar panels, different equipment on it, and there would be different workshop groups that would be held on it. And so I had to leave, but I used the rest of the budget, around $7,500, to basically to keep the project continuing. The goal was that it would continue for another year. And so this had to include all kinds of things you have to think about. For instance, transportation for public groups back and forth between these areas. You had to think about hiring, there was the ocean guards who were supposed to also ensure everybody's safety in these areas and things like that. And as well as different little mini grants for different groups to bring them out there to get them to use the different facilities on there to enable this kind of thing to happen. All of this costs money and planning and thinking about things like that. But then it was also open to the public, and it was running for probably a good 6 months or so. The idea was it was going to run for a year, and then it was going to, they were going to use all the stuff that they did on that to apply for more funding to keep it funded for more years to come and things like that. So it survived a long time of working on the ocean, having different groups and stuff like that. The big problem that we ran into is some of the people that we hired who were basically, they're like park rangers, but for the ocean, and they were also in charge of people's safety. They were apparently just chronically abusing alcohol and just passed out. And there was a group that went out there, and this group also got very drunk, and one of the adults died, and like a 5-year-old died. And it was on like, probably like, it was only, the tide was out. It was like 2 meters of water. And so, yeah, there's some real awful shit that can happen that you can't even think about or plan for, or maybe you need to plan for better and decide, all the other different aspects that will be part of your project.
Thanks a lot. That's some serious stuff that happened. It's like your insight is like, it's super valuable. So definitely you still have to think about governance and maintenance and safety on board. That seems to be paramount. Thanks a lot for sharing. Maybe we have one more question and then we should probably wrap up. I see that Tracy was saying, she mentioned, Tracy, that she's wondering who's going to manage it. Or Helian is also asking, like, will this platform be governed by an NGO? And there was also a question of scalability. Is the idea to make only one, or is it to make many of them? And who will be kind of running such a structure? So I'd like to have the answer by the students. How do you think it'll be? Because there's a diagram, I think, that touches upon that. So who runs it? Who owns it? Maybe the person who made that diagram can elaborate on how this is going to be run. Was it Nathan who made this diagram?
Oh,
No.
That's me. I'm Kelvin.
Kelvin, sorry.
From this aspect, because like what I've said, the marine laboratory to us was more like a experimentation or a demonstration of a sustainable kind of not a sustainable one, but a project that could somehow bring some effect or impact on the oceanic plastic problem. So that I think the platform would it be governed by NGO? I don't have a consensus with my colleagues yet, but then I think it's good to have the collaboration with NGO. But then we as our group would more be like managing the whole project and then ensuring it goes to the way that we have mentioned, like about the educational part. Or yeah, I think it would be more like a collaboration situation there.
Okay. There's a few people who haven't had a chance to speak or ask a question. We already a little bit past the time. I want to make sure that everybody gets to be released on time. I mentioned that we have this form to get you the feedback. Please do not forget to hit the submit button. Because without this, actually, we just don't get your data. So that would be such a waste that we don't get your data. We have several members of the ORA. I see Kenneth Wong, Chung Ho Liu, Mr. Xiang. Would you be willing to make some closing remarks?
Yeah, maybe I start first. I think I'm more interested in the computing aspect of the lab, right? Whether it is possible, to have a better framework to collect the data from various sites, and whether it is possible to have a good data center system in which make use of the advantage of the cooling effect of the sea, and how this data could be transmitted and communicate with each other, right? So if there could be some interesting things about how, for example, have a distributed system which is undersea, right? Which I don't see anything has been done before about it. Right. So most of the distributed systems you're talking about are on the ground, right? But now when you have different sites, okay, monitoring real-time data, just dynamically changing. At the same time, okay, there would be some undersea communications. Okay, how could this system could be built, right, in such a way that you can harness the various data collected from different sites and have some interesting analysis. Right? So this, I think, will be some very interesting questions in computing. Yeah.
Mm-hmm. Thank you very much.
Thank you.
Anybody wants to make some closing remarks? Pia, Tracy, some of our guests.
I guess my main thing that I would share would just be to, like, as quickly as possible, just try to like build out like 2 of these modules and just get them on some water. And I think that's going to answer a whole bunch of questions that you have, and kind of solidify and really kind of focus a lot of the things down for you, and let you know what you're able to do and what are the big challenges that are really going to be coming up. That'd be my main suggestion.
Thanks a lot. Is that how you proceeded? You made some small models, or you went straight for the big one?
Yeah, no, that's exactly how we proceeded. So we built, ours consisted of 4 big squares that then kind of linked together. But first we just built 2 of them, and then figured out good ways to connect them. We were working with a lot of local fisher people too in this little community. So there's a lot of boat building knowledge that we were able to tap into, and then test it out for this kind of novel, strange, different type of boat design thing that we had. And so we built a couple of these, figured out how, okay, they kind of float. And then we had like weeks where, you're just playing around with, 1 or 2 of these modules and figuring out what you can do with it. And then that'll help you plan for when you add on the extra parts.
Great. Thanks so much. Some closing remark, Tracy, Pia, Hillian.
Maybe I just say something.
Yeah.
I was just gonna say, the students should look at the fishermen in Hong Kong, right?
Yes.
They have their floating platforms. Go and visit them, talk to them. Take your smaller model or drawings. They have all these issues, right? Floating on sea, shelter, power, and all that. And then the other comment was, I know that apparently, right, from hearing from other marine scientists, that Hong Kong waters is very rich in biodiversity, and a lot of people from all over the world want to study Hong Kong waters. And so whether one of the users may be marine scientists that could also do the measuring, whatever data collection they can from, eventually from your floating lab. Because the 4 groups of users don't include scientists, right? Or maybe you're collaborating with them. That's one great thing about the course, I guess. Some of these master students must have done architecture before, and I think to get them to work with real people in the real world, all the different groups, and actually to make real things, that's amazing. And I think I'll think about doing something similar, maybe not quite far out in the water, but something similar, a real maker workshop type of thing. Yeah. So very good.
Thank you.
Thanks.
I think I just have something to add in terms of the location. If you are going to be measuring and taking data, it would make sense to put in a place where there's not data collection happening. So in Hoi Ha, we're already doing oceanography data collection. So actually it'd be really good to put it somewhere where you're not doing it, to be able to compare this sort of data when you get to the larger scale. So I know it would be really good to put it here because it's very convenient, but actually since we're already collecting data, maybe another location would be useful to have so we can get a lot of points in Hong Kong to compare with.
If you have suggestions on location, we would love to create something that's useful.
Yeah.
There's a gap.
Yeah. I'll see where there's gaps because we do data collection in Tolo Harbor and around Hoi Ha, but there's loads of sites that aren't being collected at. So.
Yeah. And if you can tell us what you collect, then and the instrument, then like this we can try to implement those.
Yeah.
Thanks a lot.
I just want to say this sounds like a utopia. I want to live in this platform already. I would love to. Well, I think that all of this modularism platform will down the road will produce a lot of long-term impact. So I would love to see if there is sustainable plan in place where you can actually continue the work that you guys are doing somehow, like financially or whatnot, that will eventually make some impact. Because I think if it only lasts for a year or two, then it's kind of defeated the purpose of why you're doing, this whole thing in the first place. So wherever I could help, I hope that I could help, be a part of it, financially supporting this platform, whatnot, to actually help this to happen.
Thanks a lot. I know you are trying to build a grant and gather resources for experiments like this to protect the ocean. So yeah, it's super helpful to have your perspective too. Thanks.
I just want to say quickly, it's great to see the progression from a few weeks ago. It's really exciting, all the consolidation of the feedback. I have got a lot of comments and I won't say them here. I'll put them all in the feedback form. But yeah, very exciting and looking forward to seeing the next stage. Thank you.
Thanks a lot. Great. I guess we can wrap it for today. Thanks so much for all our guests who are very, very kind to join. So if you have some feedback, please put them in this form. I'm gonna be sharing the link again. And yes, so the final testing will be June 15th. May 22nd. Sorry, May 22nd will be have something in the water. So a month from now. So you're going to see a lot of stuff happening on the wiki in the next few weeks, and we'll definitely send you an invite for the final test in the water. We might be reaching out to a couple of you who made some some suggestion, or I have a workshop with maybe David Baker and Gray to have an input on the marine biology. Then Kinzer was interested to teach about biodesign. I think Pia and Andrew can tell us a lot about the management of this platform. Helian and Tracy, I think, from nonprofits. Reynold Chen, who is very interested in data and sensors, so maybe we could also talk about that. So I'll reach out to you individually as well. about those different topics and how we can have your input maybe in a further and deeper session. Thank you so much again, everybody. Really, really appreciate your time and your input. And thanks to the students for preparing all this presentation as well.
Thank you. Thanks.
Thank you.
Bye.
Bye. Take care. Bye-bye.
Bye.
Thank you all. Well done. Bye-bye.